Well, hi, y'all. It's a Tuesday evening, and this is the penultimate. It's what the British say for the next to last class in our amateur radio upgrade series for the general class, the intermediate level in the United States. I'll be your instructor tonight, Gary, ham radio call sign Whiskey 4 Echo Echo Yankee. And tonight we're in the last chapter in the book. This book, always like to show it, the American Radio Relay League General Class License Manual, the 10th edition. That's the current version. And we go chapter by chapter each week. We divided chapter 4 over 2 weeks because there's so much material in there. And so tonight we're going to go over chapter 9 on safety. And then we'll take an intermission and we'll come back and take a 35-question practice test together as a group. You'll grade your own paper. You don't have to share how you're doing. That's okay. This is all just for you. And then if you'd like to come back next week, will be our very last class. We'll do 2 more practice tests together as a group, so to get you prepared. Come back to me just for a second. Safety is covered in the technician class, it's covered in the general class, and it's also covered in the extra class. Because safety is something that you don't get away from. You don't learn one thing and then you're done. It's an ongoing thing. And so we won't be able to comprehensively cover everything related to safety tonight, but we'll touch on those things that are valid for the exam that we have coming up. But I want to convince you that ham radio is an adventure. It's not just a hobby. It is an adventure. Why do I say that? Well, the definition is an unusual and exciting, typically hazardous experience or activity. Okay, well, Gary, yeah, this would be maybe an adventure, climbing, or if you're out in the mountains doing hiking or other kind of things like that, yeah, because there's some hazards there. Or sailboat racing at speed, oh, yeah. But I'm going to be sitting behind my radio. What's so hazardous about this? Well, this is the culmination of all of our efforts that we work to prepare for the endeavor. We don't know if we're going to be successful or not, but to prepare, we might have to climb a tower. Or we might have to do other things in order to get our equipment working. So it's an unusual and exciting, typically hazardous experience or activity. And what we're all about in learning about safety is hazard prevention. In industry, they would call it mitigation, mitigating the hazards. And so that's what we're going to get started on tonight. So here's our section for the general class. Almost done. You can almost wave those graduation helmets, but not yet. Okay, electrical safety, section 9.1. And we're going to talk first maybe about grounding your transceiver. My friend Matt, NU4E, sent me this photo. Here's a grounded transceiver. Well, okay, it's in the garden. Maybe he's growing a new one. That would be nice if we get a DX10. That's not what we're talking about. For grounding, you need to know that grounding has different purposes in mind, and there's at least 3. There's electrical safety. That's one type of grounding, and with this, local electrical codes apply for electrical safety. Then there's lightning protection, either to prevent damage from a direct lightning strike or more commonly to dissipate energy from a static charge in the atmosphere in order so you don't have a lightning strike. And then for amateur radio operators, we're very interested in RF signal ground. We want to keep our equipment at a ground potential. This helps minimize noise in signals because we're trying to hear really, really weak signals, especially on HF. And grounding, along with the grounding goes bonding. Bonding is just electrically connecting together, in this case, our radio equipment in the ham shack, using a ground bus bar there in the middle. Let me turn on my laser pointer as soon as I find my, there we go. So this is a ground bus bar here that would be connected by either flat copper strap or very large gauge wire outside to a ground rod or a series of ground rods. And by connecting your equipment all to this common ground here, it keeps everything at the same electrical potential. Now, why do I have this braided area right here? This is what we call a tinned braid, and it's great for inside. But outside, it will oxidize. And over time, you'll have a very bad connection there. So this is not good for outside. For outside connections and whatnot, you want just straight copper wire, large gauge, or flat copper strap, if you can do that. And with electrical safety, common sense applies. Don't work on live equipment unless necessary and if you feel qualified. If you don't feel qualified, well, find someone who you think does have these talents. And avoid working alone on energized equipment, for sure. And never assume that equipment is off or de-energized. Check with a meter or a tester. You don't want to be shocked. And electrical current can cause all sorts of interesting phenomena in the body. If you were to get in touch with a live wire, well, you want to be able to have a way to cut the power. It's been suggested for your ham shack, if you're building a new one, that you put a master switch for the ham shack. Or at least make sure that you tell your family where the master breaker is in your house. Because if you're shocked, you don't want your rescuers to be shocked as well. They need to remove power. Also, everything in your circuit board panel should be clearly labeled. I'm thinking about my panel. Okay, Gary, but that's what I'm telling you. It should be clearly labeled so that folks can figure out what's what, and make sure that your family knows how to turn off circuit breakers. Working on feed lines or antennas, especially if there are more than one person in the house that's a ham. If you're going to go out working on an antenna, you don't want your spouse or whatever to energize that transmission line or antenna by beginning to transmit. In industry, we have something called the lockout tagout procedure, and what that is just to disconnect it so that there's a visible means of disconnection, and put a label on it or a note saying, I'm working on this right now. That's the tag part of it. So you're locking it out and tagging it out as well. Try to make sure that you minimize the chance of electrical circuit coming through one hand and out the other, because your heart is in the middle, and that's where current can actually disrupt the operation of your heart. Use shoes with insulated soles, and as they said in shop class, remove any unnecessary jewelry for mechanical rotation or electrical contact. As I mentioned, electrical shock is the most dangerous when it travels through the heart, so that would be arm to arm or arm to foot currents. It can disrupt the heart's normal beating rhythm. 60 hertz household current is dangerous, so keep that in mind. And it can disrupt heart function. I spent 20 years with the Voice of America overseas at overseas transmitting stations, and I had a seasoned staff at most stations, folks that had been working on transmitters and high voltages and high RF output equipment for years and years and years. And when we had somebody new come in as a new technician, it was interesting to watch them. Maybe they'd just come out of school, and they were the most cautious. It was the seasoned guys, the guys that had been doing it forever and ever, who over time may have learned some, shortcuts, some bad things. So here are some lessons learned from Voice of America. Do not assume that safety systems are working. Check them. In every transmitter that we had, high-powered transmitter, we would have something called a grounding stick, which was an insulated fiberglass stick with a ground probe on the end and a ground wire that went off to a solid ground. And you would touch that stick on the B plus or the voltage points in the transmitter before you would go in. Remember, these transmitters were big enough. They had doors. You could walk inside of them. I tell you, sometimes technicians would be surprised. They'd put a grounding stick on a point that they thought the power was off, and they get a big arc coming off of it. Better that the grounding stick gets the arc than you do. Also, don't ignore what we call the two-man rule. When you're working on electrical equipment, you need to have two people there, if for no other reason than to call 911. We had that happen. We had short shifts. Normally, you might have four-man shifts working, and somebody noted a transmitter was down. This happened in Greenville, North Carolina. And a seasoned technician, somebody who knew better, but they were trying to get the transmitter up on the air, trying to make the program schedule. And unfortunately, in that case, it was bleeder resistors inside the power supply of that transmitter that were supposed to bleed off high voltage had opened up. And so there was still high voltage on the capacitors. He got in there, touched it, was killed. So it's really serious, especially on these power levels, but I don't want you to have any problem as well. Just because you got away with an unsafe practice in the past does not mean you can do it again. I had a technician in Germany who would like to check for high voltage with a pencil. He could draw arcs. No, Peter, no. You can't enjoy life if you throw it away. So just keep these things in mind. You heard me say earlier that local codes always apply. There is the National Electrical Code in the United States, and many times localities will defer and say the NEC applies here. But if there's any question about doing electrical work, make sure you have a licensed electrician, or that you're at least conversant with the codes in your community. Keep things simple. I mean, color codes. You'd be surprised where people wire up their own houses and they don't follow the color code. For electrical wiring, the hot wire is the black wire, the black insulated wire. The neutral wire is the white, and the safety ground is green. But if you go into an old house, maybe you're going to buy a house or whatnot, bring an electrical tester along with you and plug it into the various outlets. You'd be surprised. The tester will say that sometimes they wired them backwards. That's no good. You want to also, if the case of the equipment is metal, like many ham radio transceivers are, there's generally going to be a ground lug there, and you can use that to go to your common ground. Use 3-wire AC cords and plugs, because that provides the grounding for electrical safety. All of this grounding is preventing hazardous voltages from appearing on the chassis, whether it might be electrical voltage or RF voltage as well that can cause you a problem. You will hear some folks talk about, I had a ground loop problem in my audio and I cut off the big ground lead on my 3-wire cord and my hum went away. Don't do that. Figure out another way to work around that problem. That's not something that you really want to do. Use cable and wire that's rated for the expected current load. The current rating for wire is something called ampacity, the capacity for amperage. And the two most common sizes for house wiring are number 12 American wire gauge, and that's suitable for 20 amp circuits, and number 14 American wire gauge, which is suitable for 15 amp circuits. This used to be more of an issue back in the incandescent lamp time, when we were actually using more power for lighting and things than we are now. But you don't want to put a 20 amp circuit breaker on a number 14 wire, because it doesn't have the ampacity to carry the 20 amps and could actually cause a fire. And so when we're talking about the American wire gauge, here's some comparative sizes where, from the smallest to 3/0 there, the big one. Protective components, Fuses and circuit breakers, we've talked about circuit breakers. Fuses also in equipment. You want to use them so that they're rated for the voltage in use and with the recommended current rating. And the current rating, if it's a 250 amp or 250 volt fuse, you can use it in a 120 volt circuit. That's fine. That's just its maximum voltage. And then the current rating will stay the same no matter what the voltage is. The fuse, if it's a 5 amp fuse, should blow with 5 amps. And the fuse should be in the black wire lead or the hot wire lead, never in the neutral wire. The fuse might blow, but that means that still power is inside that piece of equipment. So that's why fuses need to be on the hot side or the black wire. And if you're going to have an amplifier in your ham shack, you probably want to consider having 240 volts in the ham shack. 240 volt circuits have 2 hot wires. And so a circuit breaker is placed in each of the 2 hot leads. Never in the neutral leads. Safety interlocks are something that we had going on at Voice of America. As I mentioned, the transmitters that we had there at VOA were big, and they had doors on the side, and we always had to watch out for visiting dignitaries, especially the guys from Washington that would come out to the station, and they'd be touring around the station, and if we didn't watch them, they'd go, "Oh, what's inside this door?" And they'd open the door to the transmitter. And they'd open it, and the door had an interlock in the upper corner that would sense, uh-oh, the door's open, and for life safety, would shut the transmitter down. And then we had to report back to Washington why we had an outage on the transmitter, because the VIP dignitary opened the door. Well, hams don't have transmitters generally that are that big, but tube-type amplifiers do have interlocks. And interlocks are switches that look like this right here. They sit flush in a case. I'll show you another picture here in a second. And what the purpose of the interlock is, if you pull the case, so here's an alpha amplifier, and we've pulled the case off of the amplifier, and down here, it's kind of hard to see, but there's an AC safety switch. When the case comes off, the power supply is disabled in order to remove voltage from the cabinet. So if you're going to do troubleshooting on amplifiers like this, again, you should be comfortable with this. You should be qualified. You should have knowledge about this. You can bypass the interlock in order to make voltage tests and things like that. But you don't want to, as a rule, bypass the interlock and just leave it bypassed. No, they're there for a reason. Something that's popular now in home wiring, because of its great potential to save lives, are ground fault circuit interrupters. GFCIs, you've seen them like this, are typically in bathrooms, garages, kitchens, and the idea is that they're very sensitive measuring instruments inside, and it's measuring the current that's coming out of the black wire and comparing it to the current that's coming back on the neutral lead, because that's the current that is doing work in whatever is plugged into the outlet. If, however, there's more current going out of the black lead than there is coming out of into the white neutral lead, that tells the GFCI that there's stray current going somewhere. That stray current might be going through a human, and I better shut down. So that's the whole purpose of a GFCI, and they work very fast, is to measure that balance of current between the hot lead and the neutral lead. And if the hot current is higher than the neutral, then that's an issue. There's a leakage current going on, and the GFCI will trip. Field day comes up in June, and a lot of generators are used by amateur radio operators at field day. The general rules for safety are that it should be operated in a well-ventilated area, not indoors, not in a garage. Exhaust fumes can be drawn into air intakes or windows, so you want to keep it well away from where people are because the danger of carbon monoxide poisoning. And it's always a good idea, if you're going to be operating a generator, to have a carbon monoxide detector in living and working areas. I don't want to see you refueling a running generator at field day. That's not a good idea. Have 2 generators and switch over to one while you're refueling the other. Refueling should be done by a team of 2. And there should be a fire extinguisher there as well. And you want to store fuel well away from a generator. You don't want it to ignite. Just use your head when you're doing this. Now, if you're going to be powering your house during an emergency condition, like we had Hurricane Helene here about a year ago, and a lot of folks were running generators, well, during operation and this kind of thing, you want to make sure that you disconnect from the power lines coming into your house. One way to do that is to break the seal on your meter and just yank the meter. It's in a socket. I don't know if you knew that. And you can yank it straight out. And that will give you a visible means of disconnection. You've disconnected your house from the rest of the lines that are going through your neighborhood. Then you can power your house with a generator. Now, a lot of generator systems that are professionally installed will have this transfer switch ability built in, so you can't backfeed the lines. Because backfeeding a line is a hazard to a line person who's out there working on the lines. If you feed 120 volts from your house, that transformer can take it back up to 4,000 volts and cause a life safety hazard. So you don't want that. You want to make sure you have a visible means of disconnection or a proper transfer switch. Lightning. All right, lightning. You can't tame it. There's so much power in a lightning strike that if it's going to hit you directly, that's what we have insurance for. But there are some steps and things that you can do to minimize from nearby lightning strikes. I'm talking about direct lightning strike. You can't do much about that. But nearby lightning strikes, you can mitigate. You can unplug equipment before a storm comes through. You can disconnect your antenna cables. And as Dave was talking about earlier before we got started tonight, you can take the antenna cable and throw it out the window so that everything is outside, so that if a static charge builds up on your dipole antenna, it won't get into your shack. Or you can install surge suppressors or lightning arresters, and these should be mounted outside your house or outside the building, and they should be mounted on a copper plate that is grounded, connected to ground wires, rods down below, and you can have them for coaxial cable. You can have suppressors for control lines, for rotors and things like that. There's all sorts of different things that are available to you. Grounding wires and straps should be as short and direct as possible. Avoid right angle bends. All towers, masts, and antenna mounts should be grounded. And lightning grounds should be bonded to other safety grounds and earth connections when practical. And now, if it's out in the middle of your antenna field and you've got the house, it's not likely you're going to be able to interconnect those. And when you're connecting ground wires together, use mechanical clamps, brazing, or welding. There's something called CAD weld, we'll talk about here in a second, that can join the wires solidly together, not solder. So you want lightning rods to be bonded together. Mechanical clamps are just fine. But if you're thinking about using solder like we use for electrical and electronic applications, solder joints can be destroyed by the heat of a lightning strike. And poof, and they're open, and you've got no protection at all. So that's why solder is not used. Grounds bonded together. Here we have a three-legged tower is what I'm trying to say. And each of the legs goes out to a ground, and there's a ground ring, and they're all bonded together, and there's ground rods at least 3 spots. We say you want to have a ground rod for each leg of the tower. And when you're going to interconnect them, the mechanical clamps are just fine because you tighten them down and they're not going to come loose. Or you can use CAD welding, which is a chemical welding process. So you put together a little box there and you fill it with a fireworks kind of material, and you light it on fire, and it melts and does a really great job of bonding things together. And again, lightning arresters, all of these should be located outside the ham shack. Finally, if you're going to be doing soldering for building a kit, I just built an antenna switch kit, and that was a lot of fun. But when you get all done, do what your mama said, wash your hands. Because solder is a lead-tin mix, and there's a potential for lead poisoning. So, like Mama said, wash those hands. Oh, let's answer some questions. So why should solder joints not be used in lightning protection?
Alpha.
Yes, the lightning solder joint will likely be destroyed by the heat of a lightning strike. And which wire or wires in a 4-conductor 240-volt AC circuit should be attached to fuses or circuit breakers?
Alpha again.
Yep, only the hot wires, the black wires. Although 240 volts may have black and something else. According to the National Electrical Code, what is the minimum wire size that may be used safely for wiring with a 20-amp circuit breaker?
Charlie.
American wire gauge number 12. And which size of fuse or circuit breaker would be appropriate to use with a circuit that uses AWG number 14?
Delta.
Yeah, that's less. That's 15 amp ampacity. So, and where should the station's lightning protection ground system be located?
Bravo.
Everybody see that? I want to give you time to read. Yeah, outside the building. And which of the following conditions will cause a ground fault circuit interrupter to disconnect AC power?
Bravo.
Yeah, if there's stray current going directly to ground, yep, it's going to trip off. And which of the following is covered by the National Electrical Code?
Charlie.
It's all about electrical safety of the station. And which of the following is true of an emergency generator installation?
Alpha.
Yeah, the generator should be operated in a well-ventilated area. Safety is mostly common sense. And which of the following is a danger from lead-tin solder?
Alpha.
Yeah, lead can contaminate food if hands are not washed. Yeah. And which of the following is required for lightning protection ground rods?
Delta.
Yeah, they should be bonded together with all other grounds if practical. And what is the purpose of a power supply interlock?
Charlie.
It's to ensure that dangerous voltages are removed if the cabinet is opened. And where should lightning arresters be located?
Alpha.
Outside, but where the feed lines enter the building. Great, you're doing fine. All right, moving on to section 9.2, RF exposure. So which stations must comply with FCC rules? All stations with a time average transmission of more than 1 milliwatt must comply with the FCC rules. And when we talk about radio frequency radiation, I like to go to the light bulb. You remember the old 100-watt light bulbs that drew a fair amount of current, so they would get hot. And the closer you moved your hand to that light bulb, the hotter it would get, until if you touched the light bulb, you got burned. Well, the same thing is true with radio frequency radiation, or power density from an antenna. The closer you get to it, the higher the intensity is. If you touch an active transmitting antenna, you'll get an RF burn. So you don't want to do that. So we're talking about RF exposure. Exposure to RF at low levels is generally considered not hazardous, but the factors to consider are power level, which also leads to the power density, frequency of transmission, the average exposure time, and related to average exposure time is the duty cycle of the transmission. Broadcasters, their whole job is to transmit all the time, so broadcasters have a 100% duty cycle. Ham radio operators, we're listening half of the time, typically. So we would say that for that reason, we have at least a 50% duty cycle, and then maybe less depending on the modulation modes. And the factors that determine how much RF the body will absorb, the things are power density and the frequency. And RF is not all bad. I mean, I look pretty young, right? And I'm 72. Well, they apply RF sometimes for beauty treatments. This is from Australia, but RF heats body tissue. That's something that RF does, and keeps you young maybe. But heating from exposure to RF signals is caused by the body tissue absorbing the RF energy. And power density is the intensity of the RF energy measured in milliwatts per square centimeter. And so if a power density is 10 milliwatts per square centimeter and the area is 75 square centimeters, then you can factor the total power, in this case it would be 750 milliwatts. You don't need to do that for the tests, that's just kind of an example, but power density is the highest, you think about this, near the antennas and in the direction in which the antennas have the most gain. So that's where you're going to have the highest power density. Increasing transmitter power increases power density. Okay, that makes sense. And increasing the distance from an antenna will lower the power density. And we mentioned earlier, it's a square law function, so that if you double the distance from an antenna, the power density actually goes down by a factor of 4. So in the book you saw the absorption and the limits, the specific absorption rate, or SAR. That's the rate at which energy is absorbed from the power to which the body is exposed. And safe levels of SAR are called the maximum permissible exposure. And it varies with frequency as established by the FCC. And body parts absorb RF best when the wavelength of the energy is similar to the size of the body. So you have this chart in your book. It's on page 9-10. And these are the maximum permissible exposure levels. And so on the left-hand side, on the vertical scale, we have the milliwatts per square centimeter. And on the horizontal scale, we have frequency. So here's 1 megahertz, 3 megahertz, 30 megahertz, 300 megahertz, and so on. And you see that at the lower frequencies, you'll have a higher maximum permissible exposure level. But as we move through the HF band and into VHF, this is VHF, this is the lowest maximum permissible exposure. In ham radio, the 6-meter band and the 2-meter bands are the ones that we have to watch out for. That's where the body absorbs energy the most. And then as you go up in frequency, it goes back up slightly. You also notice there's 2 lines, the solid line and the dotted line. The dotted line has even a lower maximum permissible exposure level. That's what we call an uncontrolled area. That's an area where there's RF exposure going on, but people might not know about it, like your neighbors. They might not know that you have a transmitter. Whereas if you put signs out, or if you let people know, then you can use the higher level, the controlled level. It's not a big difference, but it is some. We mentioned also duty cycle and averaging. So in our case, we're not transmitting 100% of the time like broadcasters are. So our energy is averaged over time intervals, and we can either use the controlled or the uncontrolled levels, and then we can evaluate the total RF exposure over a fixed time interval. We're transmitting half of the time, receiving half of the time. So all of these things factor into RF exposure, the duty cycle, the frequency, and the power density. And we said that all people or transmitters that are average over 1 milliwatt have to be concerned about this. All fixed amateur stations must evaluate their capability to cause adverse RF exposure, no matter whether they use high power or low power. So even if you plan, I'm just going to be QRP all the time, you still have to consider this. And a routine evaluation must be performed even if the transmitter's peak envelope power and frequency are within FCC rule limits. So a few years ago, this became a hard and fast rule. There was a grace period time of about 2 years, where if you operated your station below a certain power level, you didn't have to do an evaluation. And that's this table right here, which I think is also in your book, table 9-5. This was the old interim standard, but it is, illustrative of what we're doing here. For 160 meters, it used to be that you could transmit up to 500 watts. You didn't have to do anything. But as we move up into the VHF region, it went down to 50 watts. Then you had to do an evaluation, and then higher that, and you go up to 200 watts. Now you're required to perform an evaluation. There are no more exemptions. But it used to be the case that if you were below these levels, you didn't have to do an evaluation. Now, there are some pool questions that kind of allude to this, so don't let that throw you. Now, different ways that you can evaluate your station. There are 3 ways. One is that you can perform the evaluation by measuring the radio frequency field strength with a calibrated field strength meter that is matched with a calibrated antenna. So that's number 1. And I'll show you here in the next slide. You can buy these on Amazon. Now, maybe you don't want to buy one, but maybe your club should have one, so you could actually take it to your station and make direct measurements. You can also use computer modeling to determine the exposure levels. That's what most hams do. And it's not elaborate. We'll show you, there are a couple websites you can go to get a computer model of your station. Or you can do the math. If you've got your calculator out, you can use the FCC Office of Engineering Technology Bulletin 65. There'll be an active link, I think, tomorrow. You can go look at that. But no one does that. So this is what I bought. I have one of these downstairs in my workshop. It's a calibrated meter coupled with a calibrated antenna. I think it works down to 10 megahertz. I don't remember. It was about $270 when I bought it. I don't know what the price is now. But this is a club purchase. This is something the club might want to get just to have to do a direct evaluation, especially if you're involved with VHF. Remember, that's where we're most sensitive to, so it's always good to have something backing you up. Here's the FCC OET Bulletin 65, and then 65B. 65B specifically relates to amateur radio and doing the calculations for that. Okay, here's what most people do. They'll go to one of the websites, like ARRL, has their own RF exposure calculator. And you'll fill in information on the page about your station, about the antennas in use, the power levels, the types of modes you're going to be operating, a radio teletype or a single sideband or Morse code, and it will then do the calculation and tell you, how far away folks have to be away from antennas, or if there's hazards involved. The Lake Washington Ham Club also has an online calculator. There's also a third one, I think, HintLink. But if you search for RF exposure calculator, you'll find these. Just remember, the worst cases are VHF frequencies operating at the legal limit, 1,500 watts PEP, with high gain antennas. If you plan on doing any of those, then you most assuredly want to do a radio frequency station evaluation. And you should reevaluate the RF exposure from your station if you change to a higher power level, or if you increase antenna gain, or if you change your antenna height. Higher is better. Higher up gets you away from humans. And so that works to your advantage. You do not have to reevaluate exposure if you reduce output power with a station that's already in compliance. So make changes and reevaluate. If you have to, you reduce antenna gain or reduce the power level. Take precautions to make sure that an antenna is not pointed at an uncontrolled area like your neighbors. And the whole point is that you as the station licensee must take action to prevent human exposure to excessive RF levels. People have asked me, well, can I put an indoor antenna? I've just got an apartment, and can I put an antenna up on my wall? If you're going to use a stealth antenna, maybe up in the attic, you can do it, but make sure that the maximum permissible exposure limits are not exceeded in your home's living quarters. You don't want to, cause problems for your family. So, and remember, when you're using these kinds of antennas, you're much closer to the antenna than those with outside antennas. If you're going to have mobile antennas, place them up on the roof if you can, or the trunk, to minimize exposure to passengers. And if you're using an HT, was pointed out in the Kassler videos, he talks about the danger of holding an HT antenna up close to your head. Well, you locate the radio someplace else and use a speaker mic. That's one way to do it, or connect it up to an external antenna. And if you're going to be testing radios, always use dummy loads. Test antennas so you don't have to radiate RF energy without cause. Okay, here's more questions. What is one way that RF energy can affect human body tissue?
Alpha.
It heats body tissue. And which of the following is used to determine RF exposure from a transmitted signal?
Delta.
See that? It's duty cycle, yes. It's frequency, yes. It's power density, all of those. And how can you determine that your station complies with FCC RF exposure regulations?
Alpha.
Delta.
Alpha is correct. Bravo is correct. So by calculation based on FCC OET Bulletin 65, or calculation based on computer modeling, or by measurement using a field strength meter with calibrated equipment, all of those. And what does time averaging mean when evaluating RF radiation exposure?
Delta.
Yes, the total RF exposure averaged over a certain period of time. And what must you do if an evaluation of your station shows that the RF energy radiated by your station exceeds permissible limits for possible human absorption?
Alpha.
Yeah, take action to prevent human exposure to excessive RF fields. One thing I didn't mention, if you're going to do the computer modeling, which is probably the easiest, when you get all done, print it out and put that in a folder. And that's proof that you did an evaluation. What must you do if your station fails to meet the FCC RF exposure exemption criteria?
Alpha.
This is one of those questions I don't like the answer to. I mean, you have to reduce power, you have to do something to minimize, but they say perform an RF exposure evaluation in accordance with FCC OET Bulletin 65. See, this is a question that's based on the exemption standards. the ones that I said are no longer active. So I don't like this question, and I would have thought it would have been dropped, but I double checked and I think it's still there. So anyway, what is the effect of modulation duty cycle on RF exposure?
Alpha.
Yeah, so when we're talking about duty cycle, we're talking about the percentage of time that the station is transmitting. And so that means that a lower duty cycle permits greater power levels to be transmitted. Duty cycle is all about transmitting. And we're transmitting only half the time, that's a 50% duty cycle. So which of the following steps must an amateur operator take to ensure compliance with RF safety regulations?
Delta.
C. Charlie.
It is C, Charlie. You don't have to notify neighbors within a 100-foot radius. You don't have to have a copy of FCC Part 97.13 in the station. I don't even know what that is. But you do have to perform a routine RF exposure evaluation. And if you're going to have a vertical antenna, for example, maybe put a fence around it, a wooden fence, something that is not conductive. Keep people out. Make it a controlled area. Put up signs. You can get the RF exposure signs on Amazon, by the way. So what type of instrument can be used to accurately measure an RF field strength?
Bravo.
It's a calibrated meter and a matching calibrated antenna. They go together. And what should be done if evaluation shows that a neighbor might experience more than the allowable limit of RF exposure from the main lobe of a directional antenna?
Charlie.
Yeah, take precautions to ensure that the antenna can't be pointed in their direction. That's one way to mitigate the hazard. And what precautions should be taken if you install an indoor transmitting antenna?
Charlie.
Yeah, make sure that the maximum permissible exposure limits are not exceeded in occupied areas. That's the only, well, there are other problems with stealth antennas. They're not very efficient, but yeah, that's a big problem. All right. What stations are subject to the FCC rules on RF exposure?
Delta.
Yeah, all stations with a time average transmission of more than 1 milliwatt. Yay! All right, we go into RF exposure more in the extra class as well. It's a thing, so if you're going to be upgrading, stand by. We'll be back to this topic later on. Right, let's move on to outdoor safety. All right, and the most important thing is place all antennas and feed lines well clear of power lines. You don't want your antenna to be able to fall into a power line. You don't want your coaxial cable to be crossing a power line or even going under a power line. It's not a good safety thing. So safety rules dictate that no part of your antenna system should be closer than 10 feet from power lines. Especially if it's a tower and if it's going to fall, you want the tower to fall no closer than 10 feet. To power lines. There is an optional rule of thumb. Some people talk about, with 150 feet of the total height. It's the 10-foot rule. The 10-foot rule is the one I want you to remember. Don't run feed lines over power lines or service drops from a transformer to the house. Because, if they come into contact, you can be surprised. If you're shooting lines, if you're going to get one of these air guns, or with Bruce, he's an expert with the bow and arrow. If you're shooting lines through or over trees to support a wire antenna, remember that power lines can be hidden or just beyond the trees. So always scope out where power lines are located. Make a visual inspection before starting your installation. People should not be able to come in contact with an antenna once it's installed. You don't want people grabbing onto it and getting an RF burn. If you've got a ground-mounted antenna, like a vertical, place a fence around it. And read and understand assembly instructions before starting to make sure that everything is assembled safely so it's not going to fall on someone. A tower or mast used to raise antennas above buildings and other obstructions, well, if it requires guying, if you can, keep all lines and guys above head height. that's not practical all the time. So if you have to have a guy anchor at the ground, flag the wires. You can get tape and just to tie it on so that people won't walk into the wire. They won't, they'll have a chance to see it. I have a problem with deer. Here on my 5 acres on the property, I had a deer walk into a ground anchor on one of my receiving antennas, and they are flagged. But this was at night. It didn't help the deer any. He wasn't there. He was gone. But I had repairs to make on that one. If you're going to put up a tower, you may need to get a building permit to check with your local authorities. You need to comply with local building codes. And as we mentioned earlier, towers should be grounded with separate 8-foot ground rods for each tower leg, and the ground rods should all be bonded to the tower and to each other. Are you near a public airport? If so, you have to comply with FAA and FCC rules. Maximum height of a tower is 200 feet, but if you're closer to an airport, that can come down because of the glide path and all of that. If you're going to be doing antenna and tower maintenance, like with electrical circuits, turn the transmitter off and disconnect the feed line, locking it out, getting a visible means of disconnection. If you're going to be climbing, well, make sure that everyone has the proper safety equipment, properly rated safety harness for a climber, hard hat, gloves, and sunblock and goggles. For the ground crew, make sure they've got sunglasses. They're looking up to the tower and the sun might be there. And boots or work shoes to protect your feet. Tower rungs can dig in to the bottom of your feet. And make sure you have enough crew to do a job safely. With your local club, there's probably going to be antenna parties that you could attend and learn about everything. Volunteer to help other experienced hams. The goal is for you to get training in proper procedures, whether it be tower climbing or being on a ground crew. If you are going to climb, make sure that the safety harness, it used to be you could use a belt, but now harnesses are the accepted safety requirement. Make sure it's rated for your weight if you're the climber. Also make sure it's within its 8-year lifespan, because they go stale after 8 years. Their safety ratings are not the same anymore. So you want to make sure you have it that's up to date. Also, if you're going to have lanyards to connect up to the tower legs as you're going up, you want to have 3 probably to make sure that you're always connected, and maybe even one to go way up overhead. And they all need to be something that you can always have a connection to the tower. Safety checklists are good things. Inspect all tower guying and support hardware. If it's a crank-up tower, it must be fully nested or blocked with mechanical stops before it's climbed. Crank-up towers are not safe to climb when they're in their extended position. Inspect all ropes and load-bearing hardware, such as pulleys, and make sure that all electrical circuits that supply power to the tower are locked out and tagged out. And in industry, this is what it looks like. You can lock out the junction box, and you can have a tag like this on it that tells operators, don't energize this circuit. Folks are doing maintenance on it. Ooh, last questions. Which of these choices should be observed when climbing a tower using a safety harness?
Bravo.
Yep, confirm that the harness is rated for the weight of the climber and that it's within its allowable service life. And what should be done before climbing a tower that supports electrically powered devices?
Bravo.
Bravo.
So tower lighting, rotors, things like that. Make sure that all circuits that supply power to the tower are locked out and tagged out. And that, ladies and gentlemen, is the end of chapter 9, and it's the end of the book. Hurrah! Yeah, you made it. Yeah, you made it through the general class book. You're welcome, please, to come back and join us for a practice test after our intermission here. I want to congratulate, there are some students who have already passed their general class test. Bravo, and congratulate you all on that. If you'd like to, we always have free amateur radio classes, but we do have expenses. So if you'd like to make a cash donation or a money donation to us, there is a PayPal donate link at my website, w4eey.com. Or if you want to mail an old-fashioned check, my address is good on QRZ. Okay, that's enough of the commercial. Let's go ahead and take 5 minutes. Let's get up and move around. And while you're moving around, get a piece of paper and a pencil or a pen, and we'll come back and take a 35-question practice test. we're back. So happy to have you with us. And we're going to move on to taking a 35-question practice test. This is an actual test that you could experience when you go to your exam session. Practice tests, remember the forgetting curve that Dave talked about early on, where it's human nature to forget the material that you've learned. And the practice tests are all about reinforcing and remembering things that we covered early on in the class. So that's why we emphasize practice tests, because it helps overcome that forgetting curve. And there are 425 questions in the pool currently for the general class. And so if a test is 35 questions and there's 425 in the pool, if we could just do simple math, 425 divided by 35, you would need to take over 12 practice tests in order to cover all of the questions. So taking a dozen practice tests is not too many. I mean, 15, 20 is not too many, so that you get a chance. And you will find that there's also going to be repeats from one test to another, just because of the way the randomization of the test creation is. So take practice tests, and you can use the American Radio Relay League Exam Review website. I'll send you a URL in the email tomorrow again for that, or whatever practice you like to use. Hamstudy.org is a good one. QRZ, I think, has also practice tests. As long as they're for the current question pool, you're okay. All right, so for right now, we're going to have a blank sheet of paper. I'm going to have you number it 1 through 35. You can do that as we go along. And then mark down on your answer sheet A, B, C, or D for what you think the right answer to the question is. Just remember that on your actual test, when you take your exam, they won't be in the same order. So memorizing A, B, C, or D will do you no good whatsoever. But know what the right answer is, please. And we're going to go through the 35 questions. And if you've got your camera on right now, I can see you. So when you're done answering the question, if you just raise your hand briefly, that'll tell me when I see enough people that I can move on to the next question. When we're done with the 35 questions, I can always go back to any of the questions again, so you can take a look at those. If I go too fast, just unmute and say, Gary, can you slow down? And we'll get there. So keep calm. You can do this. And I won't read the question unless someone needs that, but when we get to the answers, then I'll read the question and the right answer for those who might be visually impaired. So here we go. Here is question 1. All right, and here is question 2. When you take your exam, you'll have as much time as you need. And question 3. If I go too fast, just unmute and tell me. Here is question 4. And now question 5. And question 6. And question 7. Next up is question 8. And now question 9. And question 10. And question 11. And now question 12. Question 13. And question 14. And question 15. And here is question 16. And question 17. And here is question 18. Question 19. And now, question 20. And now, question 21. And here is question 22. Giving you a little extra time to read there. Okay, and question 23. And question 24. And question 25. Next up is question 26. Here is question 27. And now question 28. Question 29. Question 30. And question 31. And here we go, question 32. And question 33. And now, question 34. And question 35. Are there any questions you'd like me to go back and show you again? Just unmute and let me know. If you're watching us live on YouTube, you could probably stick it there in the chat. I don't hear anybody. I don't see anybody. Let's move on then. Find out how did we do. All right. Put my glasses on so I can see what's going on here. What is the frequency deviation for a 12.21 megahertz reactance modulated oscillator in a 5 kilohertz deviation 146.52 megahertz FM phone transmitter? This has to do with multipliers, and so the frequency deviation would be 416.7 hertz, 1D. And when operating a station in South America by remote control over the internet from the US, what regulations apply? C, only those of the remote station's country, 2C. And 3, what is a characteristic of a random wire HF antenna connected directly to the transmitter? Station equipment may carry significant RF current or have high voltage there, 3D. And 4, how does the total current relate to the individual currents in a circuit of parallel resistors? It equals the sum of the currents through each branch, 4A. And 5, which of the following is used to determine RF exposure from a transmitted signal? All of those, the frequency, the duty cycle, or the power density, 5D. And 6, what signals are used to conduct a two-tone test? They are two non-harmonically related audio signals, 6B. And what is the benefit of using the opposite or reverse sideband when receiving CW? It may be possible to reduce or eliminate interference from other signals, 7B. And 8, what is the purpose of an antenna tuner? It increases power transfer from the transmitter to the feed line, 8D. And 9, what is the ratio of PEP, peak envelope power, to average power for an unmodulated carrier? In that case, they're the same, 9C. That's a ratio of 1. And which of the following conditions will cause a ground fault circuit interrupter to disconnect AC power? Current flowing from one or more of the hot wires directly to ground, a stray ground, 10B, maybe through a person. And what output is produced by a balanced modulator? Double sideband modulated RF, 11A. And what portion of the 10-meter band is available for repeater use? The portion above 29.5 megahertz at the top end of the band, 12B. And 13, when may third-party messages be transmitted via remote control? Under any circumstances in which third-party messages are permitted by FCC rules, 13A. And 14, how does a higher sunspot number affect HF propagation? Higher sunspot numbers generally indicate a greater probability of good propagation at higher frequencies, 14C. And 15, in which direction is the maximum radiation from a VHF-UHF halo antenna? It is omnidirectional in the plane of the halo, 15A. And what is the solar flux index? It's a measure of solar radiation with a wavelength of 10.7 centimeters, 16C. And what is an SMA connector? It's a small threaded connector suitable for signals up to several gigahertz, 17B. And 18, which of the following describes full break-in CW operation, also known as QSK? Transmitting stations can actually receive between code characters and elements, 18D. And 19, what happens when inductive and capacitive reactance are equal in a series LC circuit? They cancel each other, and all you're left with is the circuit resistance, so therefore resonance causes impedance to be very low, equal to the resistance. 19b. And 20, what is the maximum transmitter power an amateur station may use on 10.14 megahertz? In that band, 200 watts PEP output is the maximum, 20A. And 21, which of the following is required when participating in a contest on HF frequencies? You still must identify your station according to normal FCC regulations, 21B. And 22, on which of the following band segments may you operate if you are a technician class operator and have an unexpired certificate of successful completion of examination for general class privileges? You get that certificate by passing the general class test. You can transmit on any general or technician class band segment, 22C. And 23. When selecting a CW transmitting frequency, what minimum separation from other stations should be used to minimize interference to stations on adjacent frequencies? Think about the bandwidth the signal occupies, 150 Hz to 500 Hz, 23D. And 24, what usually happens to radio waves with frequencies below the LUF, lowest usable frequency? They are attenuated before reaching the destination, 24B. And 25, how does forward error correction allow the receiver to correct data errors? It's by transmitting redundant information with the data, 25A. And 26, how does a signal that reads 20 dB over S9 compare to one that reads S9 on a receiver, assuming a properly calibrated S meter? Well, 10 dB is 10 times, and 10 plus 10 is 20, and 10 times 10 is 100, so it is 100 times more powerful, 26B. And what is another term for the mixing of two RF signals? That's heterodyning, 27A. And 28, how does a speech processor affect a single sideband phone signal? It increases average power, 28D. And 29, what is the approximate forward threshold voltage of a silicon junction diode? That's 0.6 or 0.7 volts, 29D. And in a Class A amplifier, what percentage of the time does the amplifying device conduct? In a Class A, it's 100% of the time, 30C. And 31, what must you do if your station fails to meet the FCC exposure exemption criteria, which don't exist anymore? You must perform an RF exposure evaluation in accordance with FCC OET Bulletin 65, 31B. This was a current question from the ARRL exam review website. So, all right, which of the following would, this is 32, which of the following would increase the bandwidth of a Yagi antenna? Larger diameter elements will give you greater bandwidth, 32D. And what is the advantage of using IQ modulation with software-defined radios? All types of modulation can be created using appropriate processing, 33C. Okay, 34, you can do better than the instructor on this one because the instructor forgot to mark the answer. What procedure may be used by volunteer monitors to localize a station whose continuous carrier is holding a repeater on in their area? You can triangulate. You can compare beam headings on the repeater input frequency from their home locations with that of other volunteer monitors. Plot it on a map and you'll find them, 34A. But that's a lesson. When you get done with taking your test, make sure you haven't left anything blank. And 35, What is the equivalent capacitance of two 5 nanofarad capacitors and one 750 picofarad capacitor, all connected in parallel? Capacitors in parallel add, so the total is 10.750 nanofarads, 35C. So we want you to have no more than 9 wrong answers. Are you smiling? I see some smiles. That's good. I appreciate you. You have been a great, great, great class, and we'll continue on with more practice tests next week. Here again are the donate links. If you'd like to send any monies our way, you can go to my website, w4eey.com, or you can send me a check. Dave, did you have any thoughts tonight?
Nope, it's been a real pleasure working with you all, and we've had some very good questions, so it's good to see everybody engaged to the level that all of you have been. Thank you so much for participating.
Any comments or questions from the Zoom class?
You guys have been great, and I really appreciate all the time you put in, and it's, definitely appreciate it. And I just wish you were around for an extra class. I know you got recordings of them, but whenever I get there.
We have recordings of our last extra class, and we will have another extra class coming up in September. So
Okay.
if you want to operate for a while and then come back and join us, that'd be great. You'd be more than welcome. Any other comments or questions?
How much is the charge for you to take the test for me?
They don't let us do that, no.
I won't tell them you won't.
Thank you very much.
You betcha. All right, next week, 2 practice tests just like we did tonight if you'd like to come back. If you're taking your actual test, good luck. You can do it. I know you can. And send us an email. Let us know how you do when you pass your test.
Hey,
And you will.
Wait, I had a question.
Sure.
Okay, this is this is a little silly and very hypothetical, but I've had this nagging question in the back of my mind.
Sure.
So conspiracy theorists infamously wear tinfoil hats to block mind control waves.
Yes.
How well would that actually work?
The concept is called a Faraday cage. And the whole idea is that if you encapsulate anything completely and it's grounded, then radio frequency energy can't get in. Now, the hat on the head is probably not a good example, but at VOA transmitting stations where we had very high powered transmitters, we sometimes had to test equipment that was used with very sensitive, low-level signals, and so we had a Faraday room. It was made of copper mesh, grounded top and bottom on all sides. It had a special door with special metallized fingers that when you closed it, you were in an RF-free environment. So that will work. That will attenuate signals considerably. How much tinfoil is going to do, there's different ways that RF can come in, from the underside and whatnot. I don't think that's going to work, but the principle is there, the Faraday cage principle.
Okay, thanks. That was interesting that's based on a concept that actually works and not just further nuttiness.
And you can test this further. Take a cell phone, wrap it in aluminum foil, and then have somebody else try to call it. And see if the RF can get through.
Yeah, it might if there's enough leakage, but it should cut the
But
signal level way down.
it's really tightly packed.
Yep.
That's why we talk about preppers and whatnot. They'll get metal garbage cans. They'll put with sensitive electronics they want to survive an EMP. They'll put the garbage can lid on it and tape it with metal foil, and theoretically that's going to help them.
Yep.
We won't know until the EMP comes.
Yeah.
That's the concept.
Don't lose your phone with those anti-RF things, or else you can't find it.
There's a problem. All right, you've been great. Let's get out of here. Enjoy the rest of the evening. We'll get you out early. And if you come back next week, we'll do 2 more practice tests. Till then, 73, y'all.
Yep.
Thank you. Happy Easter.
Yep.
Bye-bye. See you
Happy
next week.
Easter. Yes, indeed.
Easter.